Hey, pre-calculus friends, we're here in section 4.7. We're looking at radical equations and inequalities. We're going to take a look at some vocabulary, and I've already set up a little bit of information here. When you have a radical equation, it is an equation with a radical expression inside of it, okay? And from this radical expression, we see that we have a restriction on what's underneath the radical. You remember, you can't take the perfect square, you can't take the square root of a number that is negative. So we know that x has to be greater than or equal to 5, right? If you think about that, x has to be greater than or equal to 5. So this equation might have some extraneous solutions. What extraneous solutions are will be solutions that fail to work, not because we didn't solve it and it looks pretty good, but it failed to work because of the restriction. So let's say we worked this problem out and we got that x was equal to, I don't know, -3. Might work fine for the equation. I'm just pulling that out of my head. It might work fine for the equation, but since -3 isn't greater than 5, we know that that's not a solution to the equation. And then finally, radical inequalities are really just inequalities that have radical expressions in them. So something like this would suffice. More of this will be explained and illuminated as we look at some examples. So here we have example 1, and we're dealing with a pogo stick that stores energy in a spring. When a jumper compresses the spring from its natural length of x sub 0, or sometimes we call it x naught, to a length x, the maximum height h reached by the bottom of the pogo stick is related to x naught and x by the following equation, by this guy right here. So m is the mass combined of the jumper and the pogo stick. G is the acceleration due to gravity. That's going to be 9.8 meters per second squared. K is going to be a constant that depends on the spring. If the combined mass of the jumper and the pogo stick is 50 kilograms and the spring compressed from its natural length of 1 meter to 0.9 meters, and if K is equal to this business here, find the maximum height reached by the bottom of the pogo stick. Okay, so we're going to use this equation, this formula to do so. So let's go ahead and plug in some information. Okay, so we have everything substituted in there, and now what we want to do is try our best to solve for h, and that's going to require us moving things around. So the first thing, let's isolate the radical by moving 0.9 over to the other side. Then we're going to simplify what's happening underneath the radical and then square both sides. And then with a little bit more algebraic manipulation, we get that h. We get h is equal to this number here. Okay, so the thing about radical equations is that you always want to plug this value back in to check because of the issue around restrictions. So for the sake of time, not for the sake of style, I'm not going to substitute it back in here because it will work out very well, and I want to get on to a few more examples. But no, you'll see it, especially in another few examples, how important that is. Here we are with example 2, and we're going to see a little bit purely how we should work this out. So let's isolate this radical by moving the 5 to the other side. X minus 5 is equal to the square root of x plus 7. We're going to square both sides, so that gives us x plus 7 is equal to x squared minus 10x plus 25. Here's the deal right now. This is what I want you to be thinking about and realizing. You know that 3 does not equal -3, but if I squared both sides, right? If I squared both sides, I get 9 equals 9. That's true. So does the result mean that the thing before it, the precedent, was true? Not necessarily. And that's what we're playing with here. When we isolate a radical and square both sides, we introduce the idea of extraneous roots, things that don't actually work in reality, even if it works for that particular problem. So let's continue with that in mind. So now how do I solve this? Well, it's a quadratic. I'm going to move everything over to one side. So I've got x squared minus, bring that over, it's 11x plus 25. If I subtract 7 from 25, I'm going to get 18. Set that equal to 0. Factor this if I can. If not, I got to pull out that quadratic formula. Hopefully I can figure out something, two numbers that multiply to give me a positive 18, yet add up to give me a negative 11. That would be minus 9 and minus 2. And so I've got my factored situation handled, and now I can solve easily for x to say that x is equal to 2 or 9. However, we need to go and plug it back in and make sure it is okay. So let's try it. If I say that x is equal to 2, then this is what my situation is, 2 plus 7 plus 5. And so the square root of that, 2 is equal to the square root of 7 plus 2, which is 9, is going to be 3. Is 2 equal to 3 plus 5? It's not. And therefore, this 2 is not a solution. Let's see if the 9 is. 9 is equal to the square root of 9 plus 7. 9 plus 7, I was about to write 17. 9 plus 7 plus 5. And so what we're going to do is add these two guys together, get 16. Square root of 16 is 4. 4 plus 5 is indeed 9. So we have a solution. So the only solution is 9, where 2 is the extraneous root or an extraneous solution. Handling perfect cubes or cube roots is going to be very similar. We're going to isolate the radical. We're going to isolate this cube root. So I'm going to subtract both sides by negative 8, and I get that negative 4 is equal to the third root of x plus 2. So I'm going to raise to the third power both sides of my equation. So negative 4 to the third power, I think, is negative 64. And then that now gives me simply x plus 2. So x plus 2 is equal to negative 64. And I'm going to solve. I'm going to throw my 2 over to the other side. And I'm getting that x is equal to negative 66. You know the deal. We've got to check it. 4 is equal to 3, or the third root of negative 66 plus 2 plus 8. Let's see if that works out. So negative 66 plus 2 is negative 64. The third root of negative 64 is what we need to calculate, but we should know that the third root of negative 64 is negative 4, as we just played around over there. And look, we got it, guys. 4 is equal to negative 4 plus 8. Indeed, that's 4 equals 4. We're good to go. So that one wasn't too bad. You'll notice this third root often is a little bit, I don't want to say easier, but is a little bit more forgiving than square roots, as we can generally take the square root of any number once it's a real number, the cube root rather of any number once it's a real number, though we can't take the square root of any number. So that's how it's a little bit easier on us, and we'll see that those problems will kind of move nicely. All right, so that's it for us and section 4.7. Let me know if there's any questions. I look forward to talking to you soon. Take care.